Hey guys, welcome back to our Java OpenGL 2D game development tutorial series. Today, I want to work on getting a not a library, but we're going to create a class that handles a lot of the tedious OpenGL drawing code for us, so that we can focus on making the game and, less on having to place vertices and everything. Like if you look in our event listener class, in the display method, which is, as you remember, where all of our drawing code will go, you see that we clear the screen, right? And that's normal. And then we set the color that we want, and we say begin with GL quads. Now I know that this is, some of you out there who are experienced will know this. For those of you who don't, this is the old-fashioned way of using OpenGL. There is a newer way that's modern OpenGL. It uses vertex buffers, and I know that it is the better way to do things. The reason why I do it like this is because I find it's a much easier way to understand. It's the way I learned it first. And I use it for two-dimensional things simply because of how simple it is. It's so simple, it makes it a lot easier to understand how OpenGL works and how our graphics are going to be displayed. It's much better, I think, for understanding the basics of doing this. And someday, you'll be doing modern OpenGL, especially if you want higher performance graphics. But for right now, this is adequate for our purposes, because I really just really think it's a nice way to demonstrate how OpenGL draws graphics to the screen. So yes, we say gl.begin, gl2.gl quads, then we place the vertices one by one, and then we end what we began right here. And this will get very, very tedious if every time you wanted to draw an object into the screen, you had to place vertices. So we're going to go ahead and create a new class. And it's still going to be in our graphics package. And I'm going to call this graphics, actually. And you know that in Java there is a class called graphics, which is passed to a draw method during regular, just regular aught or swing graphics. In Java, you get a method that's called paint or something like that, paint component. And it gets a graphics object that handles graphics and things like that. This is going to be a static, sort of a static version of that, and it's going to be internally based on OpenGL. So don't let that confuse you if you don't quite know what I mean yet. If you don't know what what Java's built-in graphics class is like, it doesn't matter. You won't need to, because I'll explain everything as we go. So what we're going to create, I'm just going to create a simple method. Public static void FillRect. We're gonna do this to start with. This is just going to demonstrate what our graphics library is going, our graphics class is going to do. And FillRect will take 4 parameters: float x, float y, float width, and float height. Now, these are all going to be measured in units, and the units that they're measured in are the units that we defined back here. Remember, I said units wide equals 10, so 1 unit is 1/10 of the width of the screen on which the game is running. Okay, and so that means, or rather, it's 1/10 of the width of the window of the game, which, since we're setting it to be full screen, is the same as the width of the screen. So units wide equals, basically, units wide is 10, so basically it's going to be 1/10 of the screen. All you need to know is this means that it's an abstract value that means that there will be 10 units in every in the width of the screen. So x is going to be the x position of the upper left-hand corner, or rather, the x is going to be the leftmost edge of this rectangle. The y is going to be the uppermost. Actually, now I forget whether we flipped the coordinate system or not, because if you're used to Java's built-in graphics, you're used to having x of 0 be all the way to the left, and a y of 0 be all the way to the top. Okay, and if you increase x, you move to the right. If you increase y, you move downwards. It's the same for the width in OpenGL. In other words, that the lower x is all the way to the left, and the higher you go in x, the more to the right you move. But I think the y-axis is inverted. And now I forget, since it's been a while since I recorded the first few episodes, I don't remember whether we've compensated for that by flipping it or not. There's only one way to find out, and that's through experimentation. So basically, the x is going to be the left-hand side of the rectangle, the y is the top of the rectangle, the width is how wide the rectangle is, and the height is how tall the rectangle is. So that's self-explanatory. And what we're going to do is basically we're going to do exactly what we did in the event listener class right here, where we set the color, we began drawing quads, we drew the quads by placing the vertices, and we ended. So what I'm going to do is I'm going to go graphics, and I'm going to copy and paste that code. So copy from here, paste from here. Now you'll see that we have a problem here. We said GL doesn't know what GL is. What's GL? That doesn't make any sense. And that's because in the event listener, we get the GL object right here. So there's a couple ways we could fix this. I think the way that we're going to do it is I'm just going to create a public static GL2 and call it GL equals null to begin with. And what we're going to do is in the display class, we're just going to say that GL equals drawable.getGL.getGL2. So really all we've done is we've gotten rid of this declaration right here and turned it into just a basic assignment to this variable. So now we can access it from here by simply saying GL2 GL equals event listener.gl. Okay, so that's just a quick way to grab the GL object. And so we set the color to, what is this, blue right now. Ideally, whenever we're drawing images, you can tint the images that whenever we start mapping images to the quads that we draw, you'll be able to tint the images using the color. For right now, we'll just set the color to be white. So that'll be 1, 1, and 1. And so that'll just be full color. It'll do no tinting on the object at all. And then it will draw a quad. And so in Event Listener, we can replace all this with graphics.FillRect, and we'll give it some coordinates. Let's say 1 unit from the left-hand side of the screen, so that's 1. 1 unit from the top of the screen or the bottom, depending on whether we remembered to flip the y-axis or not. A width of 1 unit and a height of 1 unit. And so what is 1 unit? In my case, since my screen is 1280 pixels wide, it's going to be 128 pixels because there's 10 pixels. If you remember in the renderer class, there's 10 units wide. And so each unit is 1/10 of my screen, and that means that each unit is 128 pixels. So what this actually will turn into is 128 pixels from the left of my screen, 128 pixels from either the top or bottom of my screen, and this rectangle will be 128 pixels wide and 128 pixels tall. And so if we run the code, we will quickly get an answer as to whether the y-axis is flipped. And we get this. Let me see. Did I? Oh, okay. I did something stupid. Let's see what happens if we set x to 2 here. If we set x to 2. Okay, wait a second. Why is nothing different? Okay, wait. I did something incredibly stupid. See, this is why I need to program more, and I need to get back into this series. As you can see, and some of you probably noticed, we never actually use the parameters we passed into the function. I don't know how I make that mistake, but let's fix it right now. Wow. Okay, what we're going to do is we're going to say x, since it's the leftmost, basically, since vertex 2f takes the parameters of the x position and the y position in that order. -1, anytime you see -1, replace it with x. Or anytime you see -1 in the first parameter. So that's there and there, we replace it with x. And then the rest of them we replace with x plus width x plus width. And now in the second column, the second parameter of each vertex 2f is going to be the y. So the negative 1 is going to be y. Negative 1 is y. And then the 1 becomes y plus height. And this 1 becomes y plus height. Okay, now we're actually going to get something new whenever we run the code. We're going to go back and reset graphics.FillRect to be 1, 1, 1, and 1. So when we run the code, okay, now it is working. When I said that it was the upper left-hand corner of the screen, that's actually not true, because the way our viewport is currently positioned, coordinates 0 by 0 is exactly the center of the screen. And so what's happening is, this is the center of the screen, so whenever we say that x is 1, it moves 1 unit over to the right, which is here. So that's why this line is right there. And then whenever we say that y is 1, it moves 1 unit upwards. So that's why it's right here. Okay? And then we said that the square itself should be 1 unit wide and 1 unit tall. And so it is. And so if we said, for example, that x should be 0 and y should be 0, then what we should get is a square whose lower left-hand corner is exactly in the center of the screen, and that's exactly what we get. This is the exact center of the screen, and we've got 1 unit wide and 1 unit tall. So if I said 2 units wide, then we should get 2 units wide and 1 unit tall, like that. Okay? And so if I wanted it to appear dead center in the screen, I'd just say, I just need to make sure that its lower left-hand corner is half a unit to the left and half a unit down, and then make it be 1 unit wide and 1 unit tall. So like that. You can definitely use these coordinates. If you look in the graphics class, they are floats. They're not integers. So you can use you can use these if you want. You can use floats instead of with decimal points and everything. So at -0.5, -0.5, 1, 1. We should get it exactly dead center in the screen, because we said start at -0.5 and -0.5, that's here, and then make it be 1 by 1, so it is. And let's demonstrate real quick, just for fun. Let's make it move across the screen. I'm going to create a new variable, just real quick, public static float x equals 0. And we'll set graphics.FillRect x 0, 1, and 1. And now we'll add a little thing here at the end that says x plus equals 0.1f. And so basically we're adding 0.1f every single frame. And depending on what your frame rate is, now this is a really, really bad way to make things move, because it is entirely dependent on the frame rate. Higher frame rate means objects move faster. But let's just see what happens. And look at that, it moves across the screen. I just wanted to make the movement, because so far it's been looking like we've been doing pictures, but I really want to show the power of OpenGL, and that's how quickly you can draw things, how quickly you're drawing things to the screen. Giving it a little bit of movement helps to illustrate that it's more powerful than just painting pictures on the screen. It's painting pictures that form animation. Look how smooth that is. I mean, if you've ever worked with Java's built-in 2D graphics, if you're like me, you've seen some pretty choppy stuff. I mean, even some pretty simple stuff being rendered in a very choppy fashion, and this is just so smooth compared to it. So before we leave, I'm going to get rid of the X thing right here. I'm going to change this back to like a 0, and I'm going to get rid of the X thing, because we don't actually need that in our code. And so this is the beginning of what we're going to do to abstract us from having to write this code every single time. You see right here, I've just called graphics.FillRect. I could copy and paste this line. Let's make another one that says 2, 3.5f, and 0.2f, just to draw another rectangle. And so we can draw 2 rectangles now. 2 rectangles, one of them's a bit off screen, as you can see. But see, we just randomly do that, and we get, I'm going to change that to 1 so it's on screen. And you can see that just by using this method, we can draw all kinds of stuff. In fact, I'm going to demonstrate that right now. I know this episode's probably been going on for a while, but we're going to demonstrate that with a little for loop. I'm going to create a for loop here. It's going to say for int I equals 0, I is less than, let's say 100, I plus plus. So this will loop 100 times. And in it, we're going to say, we're going to take one of our graphics lines and we're going to paste it into here. And we're just going to say FillRect at I. Okay, well, let me start again. Let's say int I equals 0. Let's say I equals -5. I is less than 10. No, I is less than 5. So this should happen about 10 times. And we're just going to say, to draw one that is at position I, 0, and then has has the width of 0.5f and a height of 0.5f. And so this means it'll draw it every 1 unit, starting at -5, going 10 units. If that doesn't make sense, it looks like this. And so we can just create a loop that draws things. In fact, if we wanted to, we could just randomly, and this is one thing I like to do to test how well a rendering system works, and that's to just randomly draw quads onto the screen like this. I'll show you. So for int I equals 0, I is less than 100, I plus plus. So this will happen 100 times. We're just going to say random equals new random. Makes sense. I'm going to press Command-Shift-O to import the random class. And then we're going to say float x equals random dot next float, which should give us a value from 0 to 1, I think. Well, a better way to do this, let's just say random dot next int, anywhere from 0 to 5 is what we'll say, so that everything will take place within around this area of the screen, the upper right hand corner. And float y equals random dot next int 5. Some of them will be off screen because of that. Float x equals realize these don't need to be floats, they can be ints, but I'll just leave them as floats, it really doesn't matter. Float width equals random dot next float, that'll just give us a random value from 0 to 1. And float height equals random dot next float, and again a random value from 0 to 1. And then we're going to draw a random rectangle. Graphics dot FillRect x, y, width, height. Everything, just these parameters right here. And so this is just going to randomly draw 100 rectangles on the screen every frame. And so they're going to randomly move. And as you can see, we're basically, the reason why they're all so neatly spaced is because we used integers instead of floats, because I didn't feel like creating a float, a random generating float thing that generates a random float within a specific range. It can be done. It's not too difficult, but I didn't want to take the time to do that, because for our purposes this is fine. But notice that every frame it's a random rectangle in each place. Each place has a new rectangle, something random. And so that's just a little fun thing to do to test to see how fast the thing really is. If I go ahead and say to do that again, but with like, let's say 1,000 instead of 100 times that it loops, let's see if we slow down at all. Still no noticeable decrease in performance, at least on my computer. What if we said to do it 10,000 times? Again, do we get a noticeable decrease? It's actually really hard to tell because now it's the squares are filling up so much with random rectangles. But on mine, it doesn't look like there's any decrease in performance. So that's just a fun way to test and see what's going on there. Before we leave, I'm going to replace this entire for loop with just the simple graphics.FillRect 0, 0, 1, 1. Just so that we've left something normal there for whenever we come back to the next episode. Now, this has probably been a fairly long episode, but it's just helping us to get a feel for what we're going to be doing with this graphics class. Soon we're going to have methods in it for drawing lines, for drawing rectangles that are not filled, and most importantly for drawing images. And there's going to be all kinds of fun stuff we can do with that. And so, again, I want to thank you very much for watching these videos, and if you have any questions, please leave them in the comments, and I will do my best to answer them if I can. And yes, again, thank you very much for watching, and I guess I'll see you in the next video.